Right, this video is going to be on imaginary numbers and then talking about complex numbers and their operations as well. So first, we want to look at what an imaginary number is. An imaginary number is a number whose square is less than 0, which is a fancy way of saying that to get an imaginary number, you take the square root of a negative. So here, the most basic imaginary number is the square root of -1, and we call it I. So taking what you've learned before, if you have the square root of -1, you take that negative and you make it a positive and you put the I in the front just to represent that that was in fact imaginary. And then the square root of 1 is just 1. So this really is just 1I, or you could just call it I. And so this is like the most basic imaginary number. All the other imaginary numbers are kind of like based off of this definition. So other imaginary numbers, so here I'm going to say make this a plus and put an I in the front, and then the square root of 16 is 4, so we can call that 4I. Here I've got the same thing, make that a plus, put an I in the front, and then I could call this I square root 8. We typically put the I in front of the square roots. You could say square root 8I as well. This is kind of like a nod to what it looks like in the quadratic formula. But we can also simplify that square root, and so if I want to simplify the square root of 8, that's 2 times 4. And then 4 is 2 times 2, and so I have a pair of 2's and a leftover 2, and so 2I square root 2 would be another way of writing that same imaginary number. To add or subtract imaginary numbers, you're going to be adding the coefficients or subtracting the coefficients. So if you needed to add 5I plus 3I, that would give you 8I, so it's going to feel pretty intuitive. Anything to the 0 here, we've got I to the 0. Anything to the 0 is 1. I to the first power is just going to be I. I to the second power is going to be the square root of -1 times the square root of -1, which we could think of as the square root of -1 squared. So if we do I to the second power, that squared and that square root cancel out, and we just get -1. And so this equals -1. I to the third is going to be an I squared multiplied by another I. And so that's going to be, I'm going to go ahead and write I to the third, 1, 2, 3. So that is an I squared, which is -1. -1 times I, so -I. I to the fourth is going to be 1, 2, 3, 4 I's, so we have a -1 and another -1. -1 squared is +1. I to the fifth is 1, 2, 3, 4, 5. We've got a pair of I's and another pair of I's, so that's a -1 times a -1, which is +1, with an I left over. I to the sixth, we've got a pair of I's, a pair of I's, a pair of I's, and so that's -1 times -1 times -1, which would be a -1. And then as you can see, it's kind of repeating this pattern. So we can go ahead and we can fill in the rest of these. All right. Is there a pattern? Yes. So some teachers teach their students to memorize the 4 different scenarios because we have 4 different options. And so they would say you need to have kind of like 4 ideas there. I don't like to do 4. I like to think of it as 2 different patterns. So you have 2 situations. You can have an even number of I's where you can look at all your pairs, or you can have an odd number of I's where you've got some pairs and then you've got a leftover. So an even number of pairs is going to give you multiple -1s. So here we had 2 pairs of 2 that gave us 2 -1s. Here we had 3 pairs of 2 that gave us 3 -1s. 5, we had 2 pairs of 2 and 1 left over. So what I'm going to say is if we were to do 17 divided by 2, 17 doesn't divide by 2, but 16 does. So that's going to be 8 i's with 1 left over. And so the way I'm going to think of that, if I have 8 i's with, or sorry, 8 pairs of i's. That was 17 i's. 8 pairs. 8 pairs with 1 left over. That means we have -1 to the 8th power with 1 I left over. Now, a negative to an even exponent means you're going to have all those negatives cancel out. I've got 8 of them. They're going to cancel. And so this answer is just going to be I. If I do 26 divided by 2, I get 13 pairs. So that's going to be -1 to the 13th power. That's odd, so my answer is going to be -1. Right? One of the reasons you kind of have to know this pattern or know these rules is because while your calculator can handle imaginary numbers, it, for whatever reason, cannot handle patterns of the powers of I. And so you have to know these because your calculator doesn't do them for you. All right. A complex number is typically written in the form a plus bi. A is a real number, 5, 17, pi, -27, square root of 53, whatever. Imaginary numbers are the numbers where you've taken a square root of a negative, all right? And so a complex number is, complicated because it's real and fake at the same time, and that makes it complex. So A is the real part, B is the imaginary part. When A is 0, we have an imaginary that's considered a pure imaginary number. It's not balanced out by having a real part, it's completely imaginary. So if we have 2 plus 5i, the real part is the 2, the imaginary part is the 5i. All right. So that part, that's kind of vocabulary just to know what they are. Next, we're going to go ahead and talk about working with complex numbers or imaginary numbers. So first, we're going to go ahead and go through combining like terms, and then we'll go ahead and do the multiplying piece. So here, this is pretty easy. You're just going to think of like literally combining like terms. So here we have 8 minus 3i is considered to be the first complex number. 2 plus 5i is considered to be the second complex number. So that leaves us with 8 minus 3i plus 2 plus 5i. We don't really need those parentheses. They're just telling us, we've got one complex number and another. So to combine like terms, I'm going to put the 8 and the 2 together. So the real number portion is 10. The imaginary number portion is positive 3i and negative 3i and positive 5i, which would be positive 2i. And so this is the resulting complex number. Here again, we're just adding. So I've got 8 plus 7i minus 12 plus 11i, and we can go ahead and combine like terms. So that's -4. And then 7i and 11i is 18i. So there's our complex number there. Here we're subtracting, and so the parentheses really are very beneficial. This time we're going to distribute that negative. We're going to make sure we minus each piece of the complex number. So I've got 9 minus 6i, and then minus 12 minus 2i. So I've got the real number portion, which is -3. And I have the imaginary number portion, which is -8i. Okay, so next we're going to look at what happens when we multiply imaginary numbers. And to do multiplication, we have to remember what the different powers are. So the two pieces you need to remember is that the square root of -1 is just I, and then more importantly, you have to remember that I squared needs to be replaced with the -1. Do you like how I wrote that? Kind of inconsistent. All right, so what I'm going to do first is I'm going to fix these and write these as imaginary numbers. So 5i, 4i. So I've got 5i square root of 2 being multiplied, and then here I have a coefficient of 4, and I did this problem already. I already know that the square root of 8 is the same thing as 2 times the square root of 2. We did that earlier in the notes. We said the square root of 8 is 2 times the square root of 2. So I'm going to say that this 4 is being multiplied by 2i square root 2. Okay, so I have 5i square root 2 times, that's 8i square root 2. And then the way that we multiply these together is we multiply the coefficients, we multiply the i's, we multiply the roots. So 5 times 8 is 40. I times I is I squared. Root 2 times root 2 is root 4. So now I can go ahead and replace this with what I know each thing is. I have 40 times negative 1 times 2. So negative 40 times 2 is negative 80, and that is what that equals. All right. Next, we have 2 terms multiplied by 2 terms, so I'm going to FOIL those, or you can write them out and multiply using the box. So I'm going to go ahead and FOIL the first one, and then I will use the box on the second one. So 8 times 2 is 16. First, outside, 8 times negative 3i is negative 24i. And then I've got the inside. 5i times 2 is positive 10i. And then I have the last, positive 5 times negative 3 is negative 15. I times I is I squared. Okay, so I've got 16. These are like terms. That's negative 14i. And then over here I've got a negative 15 that's being multiplied by a negative 1. So I've got 16 minus 14i. Negative 15 times negative 1 is positive 15. So if I combine my like terms, I've got 31 minus 14i. And you'll notice that every time I write my answers, I'm being careful to put the real part of the answer first, the imaginary part second. Real first, imaginary second, real first, imaginary second. The I is not a variable. So when you write it in this order, it might feel weird right now, but it really is correct. And if you've done math for a while, you'll look at that and it will feel right. It would feel weird for me to see an answer like this and read it as 18i minus 4 because nobody writes it that way. So just be careful that you're writing these in the correct order. Okay, for this one, I need to multiply them again, but this time I'll go ahead and use a box to do it. You can use whichever method you want when you multiply these. I'm okay with each of them. So I've got negative 6 and positive 2i, 2 and negative 3i. So negative 6 times 2 is negative 12. Negative 6 times negative 3i is positive 18i. 2i times 2 is 4i. And then 2 times negative 3 is negative 6. I times I is I squared. So I have a negative 12. I have a 4i and an 18i, which gives me 22i. And I have a negative 6 times a negative 1. So negative 12 plus 22i plus 6. And so my answer is negative 6 plus 22i is the resulting complex number.